Hello, welcome to this video presentation on reverse engineering for 3D printing. In this video, we will cover the fundamentals of reverse engineering, the process, obtaining geometric data, point cloud processing techniques, surface reconstruction, and medical application of this powerful process. So let's get started. In our previous discussion on the process chain of 3D printing, we established that for 3D printing of a part, we need a 3D model, that is basically the CAD model. We then processed with CAM to generate the code for 3D printing before finally printing a part. Essentially, it all begins with CAD model. We previously discussed how creating a 3D model of simple structure is relatively easy using primitive geometry and Boolean operations. Here on this slide are a few examples of such a simple models that you can create these using solid modeling tools. But what about the model with the complex curves as showing here on this slide? It is still possible to create such models if you have experience in CAD modeling. In this slide, these sculptures, however, are very difficult to create using basic CAD operations and the CAD philosophy as we discussed earlier. So to create the solid models of such objects, we employ the reverse engineering. The reverse engineering is a technique that involves creating accurate CAD models from existing physical objects. It is used for various purposes, such as modifying designs, understanding the architecture, and analyze the functionality. With the advent of 3D printing, replacing and fabricating copies of parts have become faster and more efficient than ever before. Now, let's discuss about the first step of the reverse engineering, that is obtaining the geometric data. To begin the reverse engineering processes, we must first obtain the geometric data of the object. For simple objects, this can be done using measuring tools. However, for the complex objects, 3D scanning methods are employed. In the medical field, geometric data of human body parts is generated from CT or MRI scans. So once we have the point cloud data, several processing techniques are applicable. A few techniques are the noise reduction, registration, downsampling, normal estimation, feature extraction, and segmentation. These steps help to clean, organize, and optimize the raw data to create the 3D CAD model. After performing these operations, the next step is the surface reconstruction. In the surface reconstruction, a continuous surface is created to accurately represent the geometry of the object. There are several algorithms available such as Poisson surface reconstruction, ball pivoting algorithm, and marching cube. This step is essential for creating accurate and detailed 3D model of object from the point cloud data. Here in this video, we will see how actually we can process the point cloud data in order to create a surface model. So here, first we need to import the point cloud data from the computer directory. This point cloud data I have already saved on my computer. The point cloud data is having the x, y, and z coordinate of each point, which is separated either by comma or some space or semicolon. So we have to specify the entity which is separating the x, y, and z coordinate of each point. Then after importing the point cloud data, we can visualize it in the MATLAB space. Here you can see the point cloud data of a teapot. To convert the point cloud data into the surface model, it is important that we have to choose the appropriate algorithm. To discuss the different algorithm is not under the scope of our lecture. So I will show you how we can convert this point cloud data into the surface model directly. So here we can select the surface reconstruction by wall pivoting. Then we can select and we can enter the different values like the radius of the wall and the other parameters. By pressing the apply button, this will generate one surface model that is not appropriate. So we can change the radius of the wall point. Then eventually we can see there is some modification in the surface. And after some iteration, we can get the complete and perfect surface model of the teapot.